Hey everybody, it's Miss Kent. I hope everybody's doing well. This is week 3 of our distance learning, day 1. I hope that everybody's getting your work done, but I also hope that you're getting to go outside and play and enjoying this time with your family. If you have any questions for me, you know my phone number, or you can send me a message through Seesaw. If you're in Miss Carissa Foley or Miss Dindlebeck's class, I know you know how to get in touch with them as well. And we can answer any questions, not just math or reading questions. If maybe you just want to talk for a minute, we're here to talk to you also. Today we're still going to continue talking about using 5 times to help us multiply. But I'm going to be throwing a little bit of area in here, okay? So as you see how I model my images, you're going to see representation of area. So be thinking back to area. When we were talking about area, that's the measurement of the inside of a flat shape, okay? So let's look. Today we're going to start out with 5 times 8, or 5 multiplied by 8. Take a minute, stop the video, and try to solve this mentally. Okay, so most of you probably knew 5 times 8 was 40. 5 times 8 was 40. Did you have to count 5, 10, 15, 20? Because remember, this is not our most efficient strategy anymore. Oh, start with 0. 5, 10, 15, 20, 25, 30, 35, 40. Okay, skip counting is not our most efficient strategy at this point in 3rd grade. Did anybody go back to this strategy that you could have done mentally? Ten times 8 is 80. 5 is half of 10. So half of 80 would be, that's right, 40. Even though we're multiplying by 5, think back to that power of 10 or using 10, because 5 is always going to be half of 10. So you can always multiply that other number by 10 and then half the answer, okay? But let's look at an area model of what this would look like. Now, we had discussed area models in class pretty frequently, if you remember. Okay, so an area model, we're measuring the inside, and this side would be your 8 because it's larger, and this side would be your 5. So if I was drawing this, I would divide this side into 5 pieces. Okay. And then I would divide this side into 8. And I'm going to use that middle point. You know, that's a good landmark point. And I'm going to have 4 on this side and 4 on this side. Now remember, I'm not drawing 4 lines. I'm actually only going to draw 3 lines. So now I have an 8 by 4. And if we remember, length times width equals area. Now, I knew that equation because I've covered area and I've worked on the area. Was it necessary for me to draw that whole grid out? That probably took a little bit of time. And, you know, if I was drawing that grid out, I was probably wanting to count all those squares. That took forever to count 40. And probably when I was counting, I might have messed up and skipped a number. I don't think I needed to draw the inside of that model. I think I could have left it like this. And this is really something you're going to see a lot of in 4th grade. And this is called an open area model. It's called an open area because there's nothing covering the area. Remember, the area is the measurement of the inside. There's nothing covering that area, okay? So you could have even looked at this open area model like this also. 5 times 4 is 20. 5 times 4 is 20. So now I know the total area of this shape, trying to change my colors up, would be 40. Okay? Open area model gives us a lot of options on how to break those problems apart, which when we're talking about multiplication, what property is it that helps us break numbers apart? The distributive property. But let's go back to our number talk. I know I'm throwing a lot in here, but we're missing a lot at school, so Miss Kent's trying to have to cram it all together. Let's look at our next equation. 2 multiplied by 8. 2 multiplied by 8. Okay, you probably were able to solve that without even stopping the video, because you know if you double 8, you get 16. Now I'm going to draw an open area model so you know what that looks like as well. If you needed to draw it, you would know it would be a 2 by 8. And you see I'm not going in and drawing all those little squares. I'm leaving it open. And well, I don't know, trying to draw this and should have started with that middle point halfway, because that always helps me when I'm dividing. Now my pieces are not at all equal, I know. Looks really bad actually. I had a big black marker. Let me fix this up a little bit with my big black marker. Okay, so I divided this into 8 pieces. Okay, so I would have, if I wanted to skip count, 2, 4, 6, 8, 10, 12, 14, 16. Okay, even if I use the distributive property to divide 8 into groups of 1, that would be 2 times 1 is 2. Okay, even though that's a little much for that problem, I don't think any of you should not have needed that at this time. So let's look at this one. Now, keeping in the back of your mind a lot of those strategies that we've already learned, there's a lot of different strategies you could use to solve this one, but think which one will be the most efficient. You're probably going to need to stop the video and use mental math to try to solve this one today. And you should have said 7 times 8 is 56. Now this is definitely an equation that we don't have an easy strategy to solve. It's one that we really had not went over in class because multiplying by 7 is tricky. 7 is one of those odd numbers we don't like to use. We have talked about a strategy for multiplying by 8, but let's think of another strategy. How did you solve this? Because I know no one said 56 like that. How did you solve it? Stop the video and talk to yourself out loud and hear yourself say how you solved this. Okay, sometimes when we say stuff out loud, we either realize, one, we made a mistake, or it kind of helps the people that are auditory learners. Even when we say it out loud, we understand it a little better when we hear it. So let's look. I'm going to use that open area model that I was using before. And you want to try to draw it to scale. So when I say to scale, I mean this side's going to be 7. And this side's just a little bit longer, so it's going to be 8. Did not get a ruler out, so I draw it to scale the best I can. It's not going to be perfect. Now, we already said 7 times 8 is one of those equations we don't know. But inside that 7, there's what 2 numbers? That 5 and that 2. So I'm going to divide this into a 5 and a 2. Now, I want you to see what my proportions look like. Do you see the side that's a 5 is larger than the side that's a 2? Okay. So I want to, like I said, draw it as close to scale or being correct as I can. 8 times 5, oh, we already had that one. 8 times 5, oh, 8 times 10 is 80, and half of that would be 40. 8 times 2 is 16. 40, 56. My answer would be 56. Now, when people talk about you knowing your math facts from memory, and I know that's something a lot of our parents want us to know. They want us to have those facts memorized. It's better to be automatistic with your facts than to have them memorized. And when I say automatistic, I mean you automatically have a strategy you can fall back on. You don't automatically say 7 times 8 is 56. Now, maybe when you're 30 years old, if you're using that equation every single day, you might have it memorized. But you should be automatistic in saying, oh, 5 times 8 is 40, 2 times 8 is 16, that would be 46. That's what automaticity is. Okay, let's look at another one. Put this one out there. 5 times 9. Stop the video. What strategy would you use? Okay, you probably came up with your answer of 45. But what strategy did you use? Because if you were counting by fives, 5, 10, 15, 20. Remember, that's not a very efficient strategy at this point. What about if I go to draw that open area model? I really don't want to divide that 5 into a 3 and a 2. And that 9, I could do a 5 and a 4. But what's another strategy that we've talked about? What about if I made this a 5 by 9 and 1 make 10? And 10 times 5 is 50. And 50 take away this 1 5 would be 45. Remember, using that 10 times is a pretty awesome strategy to have. But let's look at one more for today. And this one's kind of a mixture of everything we went over, so think about all the strategies from today. You're probably going to have to stop the video and think about it. So your answer would be 63. Now, just looking at this, I know that this is a reasonable answer. And how do I know it's a reasonable answer? Do you remember that little trick I told you? When you're multiplying anything by 9 all the way up to 10, these two numbers added together are going to equal 9. If you think about 9 times 5 is 45. 4 and the 5 equal 9. 9 times 1 is 18. The 1 and the 8 equal 9. Okay, so I know this is a reasonable answer. Okay, oh, what strategy would be best here? I think, personally, the strategy of 7 times 10 equals 70. Take away that 7 and you get 63. I think, personally, that's going to be, this is not very good drawn to scale, that's going to be your best strategy. It's to add that 1, 7, and then go back and take it away. However, if thinking about going back and using the power of 5 or using 5 times, I don't want to say the power of 5, using 5 times, what would that look like? So let's look at it. Which number do I want to divide or excuse me, which number do I want to distribute here? The 7 or the 9? I would want to distribute the 7 because 7 is a little bit harder for us to multiply by, groups of 7. So that would be a 5 and a 2. So now I have 5 times 9 plus 2 times 9. Okay, and if I look over here in my open area model, five times 9 is 45. 5 times 2 is 18. 5 and 8 make 13, so you have 40, 50, 63. Now, looking at these two strategies, which one is more efficient? Meaning, which one took less steps, I could solve it and be more automatistic with solving it, because the more steps you have, the greater chance of having a mistake. And I feel like this one right here, power of 10 or using 10, is probably the best strategy. Even though we're supposed to be focusing on using 5 right now, for me, this would be my go-to, especially when I'm multiplying anything by 9. Hope everybody has a great day. Bye.